Hello there. We are going to talk about one of the few remaining topics, something that would have been on the MCAS this year if the MCAS had happened. Surface area and volume. I know some of you have done some of this before, so some of this might be review, but big idea that I want to start with is the idea of what a prism is. So if you are unfamiliar with the definition of a prism, I'm going to go non-textbook and a little bit informal. A prism is basically just a box. What makes a prism what makes a prism special is that it is a box, something like the two that are shown here, where two of the faces, think of each one of these is made up of lots of different, well, in the first one, each face is a rectangle. In the second one, some of the faces are rectangles. Some of the faces are, I might ruin this diagram by trying to highlight it. Some of the faces are trapezoids. What makes a prism is that there will be two surfaces, two faces that are absolutely identical. They're congruent to each other, and they have to be parallel to each other. So I'm going to erase a couple of things here. You will notice that there are those little arrows that indicate parallelism. They're telling you that the four edges that are indicated there are parallel to each other. And because they're parallel to each other, that means that the two trapezoids that are on sort of the front left and the back right of this figure are parallel to each other. They're also identical, as you can tell by all the measurements that they're given. So if someone asks you to find surface area and volume of a prism, there are certain formulas that on the MCAS you'll have access to. So hold on one second. I'm not sure if this is recording that right now. I think when I changed screens, it didn't record, but I'm seeing it. Hopefully you guys are. So surface area and volume formulas are on the reference sheet that you guys get. And I'm just going to go back. But here's the big idea. You don't need a formula for surface area. Surface area is the total of all of the individual areas. So for number one, you got a bunch of rectangles. And the top of this rectangle is 9 by 12. 9 by 12. But there are two of them, the top and the bottom. Okay? 2 times 9 times 12. But I also have the right side of this, which is 9 by 8. The 8 is the height. The 9 isn't obvious, it's over here. But because it's a rectangular prism, all of these are rectangles, which means opposite edges are identical. So I also have two rectangles that are each 9 by 8. And I also have the front and the back. So here's the front. And the front and the back are identical rectangles that are 8 by 12. So I have 2 times 8 times 12. Someone wants you to find the surface area. That's it. Find the area of each individual face, add them up. I'm not going to bother going through the calculations on this. That's something you guys can handle with no problem. Let me erase all of this and make some room. And volume. All right, people have memorized that volume of a box is length times width times height, and that's great. So in this case, you would multiply 8 times 9 times 12, you'd be done. I'm going to give you something that's a little bit more useful because it applies to all prisms. Because if you try to do, for number 2, length times width times height, it's not going to work too well. So here's the thing. In a prism, I told you that there are two surfaces that must be parallel and congruent to each other. Each of those is called a base. except I'm going to make this a capital B. That's a really ugly one. Because here's the thing. In formulas, you guys have seen formulas, for instance, like the area of a triangle is 1/2 base times height. You guys know that. And you see base represented by a lowercase b. Well, when we're talking about three-dimensional objects, like prisms, or pyramids for that matter, the base, meaning a surface, is a capital B. So the volume of a prism is the area of the base. So they use a capital B. You can't interchange lowercase letters with capital letters. They sometimes mean different things. Times the height. I'm using a lowercase letter. Now the height is the distance between the two bases. So for number 2, each base is a trapezoid, and the distance between those bases would be 6. So for number 2, to find the volume, it's going to be the area of the base, we'll deal with that in a second, times 6. The area of the base is its own separate formula. If you want to find the if you want to find the area of a trapezoid, this is one of the formulas that's given on the reference sheet. But the area of a trapezoid is the average of the two, and now I'm using a lowercase b, bases. Remember that in a trapezoid, you've got two parallel sides. The average length of those two sides times the height. So for area of a trapezoid, it's the average of those two bases, which would be 8 and 5. So that means it's 8 plus 5 divided by 2 times the height. Well, they show you that height is 4.8. The way this is usually represented in a formula is they use a lowercase b with a subscript. So there's b1 and b2. Well, there's your 8 and your 5. You add them together, you divide by 2. All right, so the area of each trapezoid is 8 plus 5 is 13 divided by 2 is 6.5 times 4.8. That's capital B. It's the area of that trapezoid. Now we're going to, because we're trying to find the volume, multiply that by 6. So the volume of the pyramid is the 6.5 times the 4.8 times the 6, which is considered the height of the pyramid. So this can be confusing. Height, there's a height of the pyramid. I said pyramid, I'm sorry. The prism, there's the height of the prism, which is the distance between the two bases. That's the 6. But while we were trying to calculate the area of the base, we had to find the height of the trapezoid. So remember that base does not mean bottom. Height does not necessarily mean from bottom to top. Height would be the distance between the two bases. So the height, if we're talking about a three-dimensional object, the height here is 6, the distance between the two bases. If we're talking about the height of the trapezoid, that's again the distance between the two bases of the trapezoid, and that was 4.8. All right, I'm not going to bother multiplying out that volume. You guys can handle that. If you wanted to find the surface area of this particular prism, well, you'd find the area of each individual face. And we've already found the area of the two trapezoids. The area of the rest of the sides, they're just rectangles. This would be 5 times 6, and there are 2 of those. the bottom and the top are two different size rectangles. This would be 5, and we already know that this is 6. So it turns out that the bottom has the exact same dimensions as I guess you could call it the right side. And then the top is 6 by 8. So again, surface area, find the individual, whatever they are, rectangles, trapezoids, find the area of each individual face and then add them up. Volume of any prism is just this. So I'm going to talk about a couple more examples without necessarily doing them all out. If someone asks you to find the surface area of this particular prism, and this is a triangular prism, because the bases are triangles that are identical to each other, and those two bases are connected by rectangles. So I've got a rectangle that is 5 by 7, and it connects what in this case is the top and the bottom. And the top and the bottom are the bases, not because they're top and the bottom, but because they are congruent and parallel to each other. So if you wanted to find the surface area, you would find the surface area of the two triangles and then the 3 rectangles that connect the top and the bottom. The volume would be the area of the base times the height. Well, here's the height. It's the distance between those bases, so it's 7. The area of the base, the area of the base is the area of that triangle. And the area of the triangle is, because there's a right angle there, the area of the triangle would be 3 times 4 divided by 2. So volume here is 3 times 4 is 12, divided by 2 is 6, times the height is 7, volume is 42. All right, now, I was just talking numbers so far. Remember units. In this case, the volume is going to be measured in, I wrote square. The volume is going to be measured in cubic feet. So in number 2, the volume was cubic meters. In number 1, the volume would have been cubic centimeters. Right. Number 4, you can get into debates with people about whether this is a prism or not. Here's the thing. You will find in formula sheets a special formula that describes how to find the volume or surface area of what some people would call a circular prism. Here are the two bases. They are parallel and congruent to each other, just like there were 2 triangular bases in number 3. And the distance between those 2 bases would be considered the height. So volume is area of the base times the height, which is 10. The only difference here is that the area of the base gets calculated in its own special way. But we did that for number 3. The base was a triangle. That has its own formula. In number 2, the bases were trapezoids. A trapezoid has its own formula. So since the base is a circle, then this would be area of a circle is pi r squared. The diameter is 6, so the radius is 3. So the base is 3 squared, that's the radius squared, times pi. The distance between the 2 bases is 10, so we have 3 squared is 9, times 10 is 90 pi centimeters cubed. All right, in the instructions, it says round your answers to the nearest hundredth if necessary. So if the instructions tell you to round, then, okay, pi has a numerical value. 90 times, you would insert your decimal value for pi. multiply by 90, and round to the nearest hundredth. That's the answer they would expect. On the MCAS, they typically tell you use 3.14 for pi, and that's as far as they usually ask you to go. So 90 times 3.14, round to the nearest hundredth, you've got an answer. Surface area for a cylinder, I'm not going to worry about right now. MCAS apparently doesn't do much with surface area anymore. Okay, I'm going to do a couple more here. Find the surface area and the volume of the pyramids. A pyramid is basically a prism that only has one base. So if this base had a matching base up at the top, then you'd call it a square prism. Here's the thing about pyramids. A pyramid is exactly 1/3 the volume of the sort of matching prism that would have had two bases. So if you just pretended that this thing was a prism with a 7x7 base at the bottom and a 7x7 base at the top, then find the volume, divide by 3, and you've got the volume of the pyramid. All right. What I did here was I made two diagrams that were supposed to be identical, and I realized afterwards they have different units. So let's go with centimeters. Let's just pretend that those are centimeters there. These are meant to be identical, and they give you some different measurements. They both have 7x7 square bases. The difference is that this first diagram shows you something called a slant height. This does not need to be something complicated. What it is it's the height of each of the triangles that go from the base to the vertex of the pyramid. So picture taking one of those triangles and focusing on just that triangle. The height of that triangle would be go from the base up to the top here, and that's the height of the triangle. That's the 9.7. Now the height of the pyramid is different. When you're talking about pyramids, there's a slant height, which in this case is approximately 9.7. And then there's an actual height. The height of a pyramid is, imagine if this was like, if each pyramid was sort of a tent, and this was the center pole that supported the tent. It goes from the base, directly from the center of the base, directly up to the vertex of the pyramid. So the reason that we're talking about, so this is, wow, dyslexic spelling. Pyramid height. The reason I gave you both and separately is because sometimes they will only give you one and not the other. Now, if you are trying to find surface area, you care about slant height because you're focusing on the individual triangles. So the surface area in number 5 would be, well, it's got a square in the bottom. That's easy enough. There's a 49. But then you're adding up 4 triangles. And each of those triangles is identical. And each one of those triangles is 1/2 a base, which is 7, times the height of each triangle is 9.7. So the surface area the total surface area would be 4 triangles, and each one is 1/2 base times height. So 1/2, 7 times 9.7. And then you have to add the area of the square at the bottom. I won't bother doing the calculations. You guys can handle something like that. All right. Number 6 is the same diagram, except that they gave you the actual height of the pyramid. Now that would be more useful if you were finding volume, because the volume for a pyramid, I'm doing it again. That's really bizarre. The y comes first. The volume for a pyramid is 1/3 the area of the base times the height. So in this case, the volume for that pyramid would be 1/3. The area of the base is 49, and the height is 9. Multiply those out, you've got your volume, and it would be measured in cubic centimeters. Okay, wrapping this up. Number 7, let's just stick with volume. The goal was to try and make sure we got you to volumes. In this case, they gave you the slant height. That doesn't help you directly with volume, because what we need is this measure. We need the height of the pyramid. We need the height of what that sort of central pole would be if it was supporting this thing like a tent. So consider that what you have is you have a length that's 10. You have a length that is, well, I'm not sure, but can you tell what that edge is that I just, here, I'll put it in a third color. What that green edge is. Well, if this is 12, does it make sense that the green edge shown in that triangle has to be 6? Hopefully that does. So here's the thing. If we want to find the height of the pyramid, you very often have to do a Pythagorean theorem problem. So I'm going to say that 6 squared plus, I don't know what the height is yet, h squared equals 10 squared. So that means h squared equals 10 squared, which is 100, minus 6 squared, which is 36. So h squared is 64. I'm pretty sure h is 8. So to find the volume of this figure, we've got volume equals 1/3. The area of the base is 144. The height, it turned out, was 8. There's our volume. Now, multiplying that out isn't that difficult, so I'll let you guys handle the multiplication. 144 times 8 divided by 3, there you go. And it would be in cubic inches. Number 8, I'm not going to do out. I'm just going to point out that this would again be the area of the base. In this case, it's a rectangle, but it doesn't have to be any particular shape. Pyramids can have square bases like number 7, rectangular bases like number 8. So the area of the base would be 12 times 5 is 60. The height is 10. And some people would just say, we'll divide by 3 when we're done, as opposed to multiplying by 1/3. Same thing. Number 9, this is a triangular based pyramid. So, whoops, I'll go back to blue. The base of your pyramid is a triangle. That triangle appears to have a right angle here, so its base and height are the sides that are perpendicular to each other. So it would be 6 times 8. So the triangular base is 6 times 8 divided by 2. That's 48 divided by 2 is 24. So the area of the base is 24. We're multiplying that times the height, which it turns out is 7. So the volume is area of the base times the height divided by 3, or multiplied by 1/3. Okay, number 10, last one. Some people call it a cone. I might call it a circular pyramid. Here we have a square pyramid for number 7, a rectangular pyramid for number 8, a triangular pyramid for number 9. Call this a circular pyramid. Volume is 1/3 base times height for all pyramids. Turns out it's the same thing for a cone, because a cone is really just a circular pyramid. The only difference is that here, the area of the base has to be found using a circle formula. So for number 10, the volume is, the area of the base is, well, this is a diameter of 8, so the radius is 4. So the area of the base is 4 squared times pi. There's your area of the base. The height of the entire cone or circular pyramid is 9. So there's your height, and the whole thing has to be divided by 3. And this would be it. There's a little bit of calculation to be done here. And if they tell you they want a decimal value answer, instead of leaving it in terms of pi, you would insert 3.14, do the calculations, and round off. If they wanted it to be left in terms of pi, then I would say, I can do this. 9 over 3 is 3. 4 squared is 16. Times 3 is 48. I would say this is 48 pi. Kind of strange that this is measured in kilometers. That would be a really large cone. 48 pi cubic kilometers, rounded to a decimal number if the instructions tell you to. And that is it. That's what we're looking for you to be able to do. 10 examples might have been a bit much, but I wanted to show you one of each type.